Early atomic models. Thomson's atomic model, 1898. According to this model, the positive charge of an atom is thought to be distributed uniformly over the entire body of the atom with electrons embedded in it, similar to the seeds of a watermelon, so as to make the atom electrically neutral. Lenard studied the passage of cathode rays through a material in the form of thin film. He found that most of the cathode rays passed through. He concluded that the atom must have a lot of empty space in it. So, he proposed that atoms consist of electrons and similar tiny particles carrying positive charges. But he did not propose how they were held in the atom. Various features of the atom, like stability and mass, could not be understood from this model. Rutherford's atomic model, 1911. In order to understand these features, Ernest Rutherford carried out a series of experiments from 1906 to 1911 on scattering of alpha particles from gold foils. Note that an alpha particle is a positively charged particle. Let's look at the behavior of these particles when they approach the interior of the atom. Rutherford observed that most of the alpha particles, like A and A', pass through the atom undeflected. Some of the particles, like B and B', get scattered by the atom at smaller angles of deflection. The particles like C and C' undergo large deflection at an angle less than 180 degrees, but more than 90 degrees. The particles like D get deflected or rebound such that they are sent back as D' with an angle of 180 degrees. Such large angle deflections require strong forces to be acting on the alpha particles. Rutherford argued that this would be possible if all the positive charge and the mass of the atom was concentrated in a very small central region, which he called the nucleus of the atom. Then, the large angle deflections of alpha particles are due to the electric repulsive forces caused by the nucleus. From the data obtained in this experiment, Rutherford calculated the radius of the nucleus and found it to be shorter than 2.4 into 10 to the power of minus 15 meters, or 2.4 quadrillionth meters. Because the mass of an electron is only about 1/7000th the mass of an alpha particle, the effect of the presence of electrons inside the atom on the deflection of the alpha particles can be safely ignored. From his experiments, Rutherford proposed an atomic model consisting of a central, massive, positively charged nucleus made up of particles called protons. Outside this nucleus, there are electrons which move around it at some separation. The space between the nucleus and the electrons is largely empty. However, the size of the atom is determined by the distribution of electrons around the nucleus. The amount of positive charge on the nucleus is exactly equal to the total amount of negative charges on all the electrons of the atom. However, according to electromagnetic theory, such circulating electrons should radiate energy continuously. If this is so, gradually the electrons will lose energy by circulating in circles of decreasing radii. After some time, they should fall into the nucleus. This will lead to the collapse of the atom. However, this does not happen and the atom is stable. Therefore, the Rutherford model cannot account for the stability of the